When you see those sleek countertop gardens, it's easy to get pulled in. You watch perfect, bright green lettuce sprouting in a spotless white pod, and it looks like the future of food. The pitch is incredibly appealing. We are sold the idea of harvesting fresh greens in exactly 30 days, with zero weeds to pull and a steady, year-round supply regardless of the season outside. But traditional gardening has a massive, invisible safety net: dirt. Soil acts as a biological buffer. If you overwater your plants or dump too much fertilizer, the earth absorbs the shock and slowly releases nutrients over time. When you transition to hydroponics, you completely remove that safety net. You are stripping away the earth and plunging the bare roots directly into an aquatic environment. Without the soil to absorb your mistakes, the system becomes entirely unforgiving. A sudden drop in oxygen or a wild swing in pH can kill your entire crop in 48 hours, leaving no room for a recovery. To survive the steep learning curve of growing in water, you have to stop thinking like a traditional gardener. You are now managing a precise system of chemistry and fluid dynamics. This chart highlights the gap between the marketing and the execution. True hydroponic success relies entirely on understanding these chemical and mechanical trade-offs long before you ever purchase your first seed. The fastest way beginners fail is by underestimating the water. In a soilless system, every gallon in your reservoir must be manually balanced to contain the plant's entire nutritional requirement. This requires precise tools. You must use an electrical conductivity, or EC meter, to constantly measure the density of the nutrients dissolved in the water. Too weak, the plants starve. Too strong, and you burn the roots. For hydroponics, keep water tightly constrained in this green zone, between 5.5 and 6.5. Makeshift fixes like vinegar quickly destabilize the system. Outside this specific pH window, plant roots lock up. The nutrients remain in the water, but the plant starves anyway. This is why standard tap water is usually a liability. It is loaded with chlorine and heavy minerals that immediately interfere with nutrient absorption. To guarantee purity, you typically have to rely on filtered or reverse osmosis water systems. The trade-off for achieving that perfect dirt-free growth rate is a daily commitment to chemical testing and the upfront cost of filtration. Once the water chemistry is balanced, you have to keep the root zone alive through mechanical hardware. Plant roots naturally breathe oxygen. If you submerge them without aggressively oxygenating the water, they will drown, resulting in a slimy, irreversible root rot. To prevent this, you have to install active hardware, air stones or diffusers, directly into the nutrient reservoir to constantly agitate the water. But oxygen only stays dissolved if the water is cool. You must maintain the reservoir between 65 and 75 degrees Fahrenheit. In warmer rooms, that physical requirement might mean purchasing an expensive electric water chiller. Then comes the manual labor. Reservoirs and pipes require strict weekly cleaning, sanitizing the system with food-safe disinfectants like hydrogen peroxide between every single harvest. Skipping this maintenance routine allows biofilm to build up on the surfaces, triggering algae blooms that clog the nutrient tubing and suffocate the entire system. You are trading the quiet, passive-active outdoor gardening for an active network of noisy air pumps, circulating water lines, and mandatory mechanical chores. The focus on water often blinds beginners to the third major point of failure: the environment directly above the tank. Indoor grow spaces naturally trap moisture. Stagnant air and high humidity create a perfect breeding ground for powdery mildew and leave you with weak, brittle plant stems. You have to force artificial airflow. This means running oscillating fans across the canopy and often deploying a dehumidifier to hold the room's relative humidity strictly between 50 and 70%. It also requires discipline in how you map out the system. Plants need aggressive spacing so that the air can actually circulate and the artificial light can penetrate down to the lower leaves. To protect the health of your crop and prevent disease, you have to intentionally leave empty space on the rack, actively sacrificing your total yield per square foot. These strict mechanical and chemical demands are exactly why your choice of crop dictates your chance of surviving the first month. For your very first system, you need plants that can absorb a few mistakes. Vegetative greens like lettuce, basil, spinach, and mint are highly forgiving. These crops act as training wheels. They will tolerate slightly wider swings in your pH levels. and their shallow root structures are perfectly adapted for the simplest deep water culture setups. Unfortunately, beginners often want to skip the greens and go straight for fruiting plants. Crops like strawberries and tomatoes carry a massively elevated risk profile. To generate fruit, the plant demands rigorous scaling of your nutrient density, strict lighting schedules that exceed 12 hours a day, and the manual labor of hand-pollinating every single blossom. Attempting to grow a strawberry without understanding your water chemistry guarantees failure. The leafy greens provide the rapid, low-risk harvests you need to actually learn how your hardware behaves. Hydroponics replaces the slow, forgiving rhythms of soil with the absolute precision of engineering. You are micromanaging nature. This matrix plots maintenance effort against margin for error. Beginners belong bottom left. Focus entirely on basic greens, calibrating pH, and blocking algae. Producing fruit puts you top right, where the error margin is 0. You must front-load automated dosers and reverse osmosis systems to survive. In a soilless system, the most expensive mistake you can make is impatience. Master the water first, master the basic lettuce second, then complex harvests will follow.